Section 11.3, Geometric Sequence. The geometric sequence is the ratio between consecutive terms. When you have a constant ratio, we call it R. When we did arithmetic, we had a constant difference, which is D. Now we're calling it R. It's called the common ratio. So, in this given sequence, first thing we're asking is it geometric? Previously, we did the second term minus the first term to find the common difference. Now that we want the common ratio, we're going to take the second term and divide it by the first term, the term in front of it. So 15 divided by 5 equals 3. Check to make sure it works by picking the next term, which is 45. Divide that by the term in front of it, which is 15, and you still get 3. So your answer is yes. It is geometric. Then it says identify the common ratio. The ratio is that number you keep getting for dividing, which in this case is 3. Now we're going to go to the second example here. And again, answer that first question. Is it geometric? So we go to the second term. And we're going to divide by the term in front of it. So second term divided by first term gives us 2. And we check it again. The next term, 6 divided by 4. 6 divided by 4 is going to give us a decimal. If those two don't match, then our answer is no. We're not going to find a common ratio, 2 and 1.5. Therefore, it is not a geometric sequence. So now we have the geometric sequence formula. Just like last time, a to the n is the nth term. Remember, if I ask you for the 20th term, then n equals 20. If I ask you for the 100th term, n equals 100. And again, a to the 1 is still going to be your first term. N is the number of terms. R is the only thing that's different from our previous formulas. R is the common ratio. So the question is to write the formula for this geometric sequence, then find the first 5 terms. So the first thing we're going to do is write the formula. The formula is up here. So I'm going to write a to the n equals a1 times r to the n minus 1 power. And it's important we pay attention to how we plug these in. Now they want to know the first 5 terms. Well, a to the 1 is already given. So the first term is 3. Remember, if we ask you this, if we ask you for the first 5 terms, you have to plug in the letter n. You have to plug in the letter n 5 different times using 1, 2, 3, 4, and 5. A1 was given. You're still going to have to do A2, A3, A4, and A5. So A1 is done, so now we're going to do A2 using the same formula. So A2 means a to the 1, which again we said is the first term, and they gave it to us as 3 times. Now it's important to put this in parentheses so when we plug it into our calculator we get it right. So we're going to do times, and then it says R. So we need to calculate R, but in this case it's given to us. -2 to the n minus 1 power. Again, if we're plugging in n, we want the second term, then we put 2 minus 1. And you can plug that directly into your calculator. So we're going to use our calculator and plug in exactly as we see it. 3 times, and remember to put it in parentheses, -2 to the, and this is how we get the power, and this is really important, use parentheses. If you don't use parentheses, it's going to take it to the second power. Okay, and it gives us -6. So A2 is -6. And given that R is -2, isn't 3 times -2 -6? That should still work, right? So now let's find out a to the 3rd. Again, term 1 is 3, we're still having negative 2 as our n. And then to the n minus 1, if we want the third term, we got to do 3 minus 1. So if we bring our calculator back up, plug in 3 times, and again parentheses, negative 2 is that common ratio to what power? Well, we have the third term minus 1, and enter, and it gives us 12. So a to the third equals 12, and that should make sense because, again, negative 6 times negative 2 gives us 12. Now we're going to do it for the fourth term. And yes, you are going to have to write these out. A sub 1, still the first term. Parentheses, we're still putting in negative 2 because that was our ratio there. And now because it's the fourth term, we're doing 4 minus 1. So on your calculator, we're going to do 3 times parentheses negative 2. Close your parentheses. To what power? The 4 minus 1 power. We need it in parentheses. Otherwise, it won't work. It's negative 24. Now, by now, you might be noticing the pattern and think, oh, if I just multiplied each of these by negative 2, it would still work. And that would be correct, but we need practice writing the formula and filling things in. One last time. We need to plug in a to the first, which they are, or a sub 1, which we already told us was 3. Then we need to plug in our common ratio, which they told us was negative 2. And we need to plug in n. Well, if this is 5, then I'm doing 5 minus 1. So again, on your calculator, 3 times parentheses negative 2 is our ratio to what power? Got to put in parentheses, 5 minus 1. Close parentheses, enter, and we get 48. Positive 48. You'll notice that each one we go, you had to multiply it by negative 2 for it to work. And that is how you find the first 5 terms in a geometric sequence. Homework is page 606, 2 to 20 even. And make sure for those last few problems that you are writing the first 5 terms.